morning. Suppose we have a circuit like this and we are asked to calculate the current in the branches. It looks a little bit complicated, but we will manage to solve the problem. First of all, we have to calculate the equivalent resistance, and later we'll use the current divider to calculate the rest of the currents. I will give you the equations for the current divider. First of all, the current divider, when we have two resistors in parallel, we can calculate the branch currents in function of the main current. So this is so it means I1 Ohm's law is V over R1, and I2 is equal to V over R2. We know that the main current is, or the voltage is equal to the equivalent resistance multiplied by the main currents. The equivalent resistance of two resistors in parallel is R1, R2 divided by R1 plus R2 times I. If we replace V in these equations, we will get I1 is equal to R2 over R1 plus R2 times the main current, and I2 is R1 over R1 plus R2 times the main current. And the current divider, we will use it when we have two resistors in parallel. For example, R9 and these two are in parallel, R7 and these four resistors are in parallel, R5 and these are in parallel. So we will use, when it's needed, the current divider. Let's start by calculating the equivalent resistance, because with this we can calculate the currents in the branches with the current divider method. The equivalent resistance, if we start, we have, we call it the first step, R10 plus R11 are in series, first step. Second step is that these two are in parallel, and here we will use the current divider between these two to calculate I9 and I10 in function of I8. This is second. Later, R9, later we'll add R8 because it's in series with this, the 3. This is the third step. Fourth step, we have R7 that is in parallel with all this, and here we can use the current divider to calculate I7 and I8. Okay, if we go further, now we add R4. This is fifth step, and now these are in parallel with R5, 5, and here also we can use current divider to calculate what? To calculate I2, okay, I2 and I6, I2 and I6, that's right. And now we add R6, seventh step, and later these are in parallel with R2, and here we can use current divider to calculate the current flowing in I2 and I6. That's right, I2 and I6. And the last step is R1 and R3 are in series, and this is the equivalent resistance. Let's call this one R, first step R1 prime. This is R10 plus R11, and this is 1 plus 5, it's 6 ohms. Let's call this R2 prime. R2 prime is R1 prime in parallel with R9, and here where we are going to use the current divider. This is R1 prime times R9 over R1 prime plus R9. R9 is 3, 6 times 3 over 6 plus 3, it's 2 ohms. We go to R3 prime. R3 prime is R2 prime. R2 prime plus R8. It's 2 plus R8 is 4. It's 6 ohms. Now we go to R4 prime. Is R3 prime in parallel with R7, and this is 6 times 7, 3 over 6 plus 3, it's 2 ohms as well. Let's go to R5 prime. It's R4 prime plus R4. It's 2 plus R4. R4 is 4, so it gives us 6 ohms. Let's go to R6 prime now. R6 prime is R5 prime in parallel with R5, and this is R5 prime times R5 over R5 prime plus R5. This is 6 times R5. R5 is 3 over 6 plus 3. It's 2 ohms. Now let's go to R7. R7 prime, it's R6 prime plus R6, and it's 2 plus R6. R6 is 4, so it's 6 ohms. R8 prime now is R7 prime in parallel with R2, and it's R7 prime times R2 over R7 prime plus R2, and it's 6 times R2. R2 is 3 over 6 plus 3, it's 2 ohms. We end up with R equivalent, which is R9 prime, is equal to R8 prime plus R1 plus R3, and it's 2 plus 2 plus 2, and the result is 6 ohms. Let's write the values here. R1 prime is 6 ohms, R2 prime is 2 ohms, R3 primes it's 6 ohms, R4 prime it's 2 ohms, R5 prime is 6 ohms, R6 prime is 2 ohms, R7 prime is 6 ohms, and R8 prime is 2 ohms. We will use these resistances to calculate the currents in the branches. Now we can calculate I1. I1 is V over the equivalent resistance, and it's 18 over 6. It's 3 amps. Now, using current divider, as I said, current divider, we can use current divider to calculate, for example, here, knowing I1, we can calculate, knowing I1, we can calculate I4 flowing here, and no, I2, first of all I2, and I6, because these which I called R7 prime are in parallel with the R2. So I2 is R7 prime over R7 prime plus R2 times the main current, which is I1. R7 prime is 6 over 6 plus R2. R2 is 3 times I1, which is 3. So it means it's 3 times 2 times 3, and 3 times 3. The 3 will simplify. 3 times 3, 3 times 2 times 2. So it's 2/3. So it's 3 times 2 over 3 times 3. It's 2/3 of 3, so it means it's 2 amps. 2 amps. And I6 definitely will be I1 minus I2, and this 3 minus 2, it's 1 amp. Having calculated I6, we will use I6 now to calculate, because I6 to calculate the current flowing in this resistance, and I4. Using I6 we can calculate I5 and I4. I4 using I6, and I5 will be I6 minus I4. So it means I4 is R5 divided by R5 plus the equivalent resistance of this. Equivalent resistance R5 prime. So it means it's R5 is 3 over 3 plus 6. It means 9 times I6, which is equal to 1. So I4 is 1/3. 1/3 of an amp. And here we have 1 minus 1 over 3. It's 2/3 of an amp. Okay. Now, knowing I4, I can calculate, knowing I4, I7 and I8. So yes, I4 minus I7. I7 is the equivalent resistance of this 4 resistances, which is R3 prime, over R3 prime plus R3. So R3 prime is 6 over 6 plus R3. R3 plus R3. No, R3 prime plus R7, because R7 is in parallel with R7 is 3, so it means it's 6 over 9, 6 over 9, 3 times 2 over 3 times 3, it's 2/3 of I4. I4 is 1/3, so it means it's 2/9, and here it's I4 1/3 minus 2/9, it means 3/9 over is 1/9 of an amp. Okay, now we are left with knowing R8, we can calculate I9. I9 is R1 prime over R1 prime plus R9 times the current I8. So it means R1 prime 6 over 9, 6 plus R9 3 times 1 over 9. So it's 2 times 3, 2 times 3, here 3 times 3, it's 2/3 of 1/9, it means it's 2/27 amp. And I10 now we can calculate, which is equal to I11, and it's I8 minus I9. I8 is 1/9 minus 2/27. Here it's 3 times 3. It's 1/27 amp. And that's it. I finished the exercise and I thank you very much for your attention.